Hi there. For this video, we'll be showing more examples on how to solve systems of linear equations using the elimination method. So recall that the elimination method is done by first eliminating one of the variables by multiplying a certain factor to one or both of the equations, then adding them both. To understand this better, let's recall the example in the previous video. So in this one, take note that what we did here is we multiplied -3 first to the second equation to obtain 3x plus y equals 15 and -3x minus 6y equals -30. Observe that upon adding these two, 3x minus 3x will be 0 and we'll be left with -5y equals -15. Then to obtain y, we divide -5 both sides to get y equals 3. From here, we use this obtained value of y and plug it into either the first or the second equation. In this case, we plug it into the second equation, so we get x plus 2 times 3 equals 10. This simplifies to x plus 6 equals 10. Move 6 to the right and we get x equals 4. Using the two values that we obtain, we conclude that the solution for this system of linear equation is the point 4, 3. So that is how we apply the elimination method. Now let's try out more examples applying this method. So let's have this first one. We have x plus 2y equals 4 and 2x plus 4y equals 1. Before we start, feel free to pause the video so that you may try this one first on your own. So let's start. So first, we choose which variable we want to eliminate. In this case, let's first try to eliminate the variable x. What we can do is we can multiply -2 in the first equation, so we get -2x minus 4y equals -8 and 2x plus 4y equals 1. Then adding these two, and we get first -2x plus 2x would cancel out, but observe that -4y plus 4y would also cancel out. So therefore, this would simplify rather into 0 equals -7. And what does this mean? Well, we know that this equation isn't true since 0 is not equal to -7. So we have a contradiction since 0 is not equal to -7. This means that whatever value of x and y we choose, these two equations would never have a solution or would never intersect. Therefore, the answer for this is no solution. And why is that? Can you observe what is common in these two equations? Well, if we check out its graph, these two lines are actually parallel. And we know that when two lines are parallel, they never intersect. So indeed, these two lines would never have a solution. So we don't have a solution for this system of linear equation. So that is the case for parallel lines. So did you got this one correctly? I hope you did. Let's move on to the next one. Let's have x plus 1/2 y equals 1/2 and 8x plus 3y equals -3. Again, before we solve this, feel free to pause the video so that you can try this one on your own. Good, so let's start. So in here, Let's try to eliminate x again for this one. But if you eliminated y first, there's no problem with that as long as we get the same answer for this problem. So, what should we multiply to the first equation in this case so that we can eliminate x? Well, since we have 8 out here, we can multiply negative 8. So that would give us negative 8x minus 4y equals negative 4, since negative 8 times 1/2 would give us negative 4. Negative 8 times 1/2 out here as well would give us negative. So adding these two, negative 8x plus 8x would cancel out, and so we'll be left with negative y equals negative 7. Since our goal is to find the value of y, we multiply negative 1 both sides to get y equals 7. From here, what we do is we use this value and plug it into either the first equation or the second equation. In this case, let's try to plug it in the first equation. So we'll have here, plugging it into the equation 1 or the first equation, that would give us x plus 1/2 times 7 equals 1/2. Simplify this and we have x plus 7 over 2 equals 1/2. Move 7 over 2 to the right and we get x equals 1/2 minus 7 over 2. Subtracting these two numbers will give us x equals negative 6 over 2 or negative 3 when simplified. So we now have a value for x and y. Now, given this, we can now obtain the solution to this linear system. So using these two, the solution is negative 3, 7. And so that is the answer for this problem. And indeed, if we check out its graph, although it's quite small, you can see that the intersection is indeed at negative 3, 7. Let's try out one final example. In here, we have x minus 2y equals 1 and y minus 1/2 x equals negative 1/2. Before we solve this, again, feel free to pause the video and you may try this one out on your own. Good, so let's try this one out. So in here, first, it's kind of hard to see how we can eliminate one of the variables since x and y doesn't match out here. So we first rearrange one of the equations. In this case, let's rearrange the second equation. So we just switch the place of the x and y. So we have negative 1/2 x plus y equals negative 1/2. And now it's easier to see what we should multiply in order to eliminate a variable. In this case, let's try to eliminate x. So what should we multiply out here? More specifically, what should we multiply, let's say in the second equation, to remove x out here? Well, we can multiply 2 in this case, since negative 1/2 times 2 would give us negative 1. So that will give us x minus 2y equals 1 and then negative x plus 2y equals negative 1. And from here, let's add these two equations. So x minus x would cancel out, but observe that negative 2y plus 2y would also cancel out. And so is 1 minus 1. So this seems similar to our first example. But observe that what we'll have here is 0 equals 0, which we know to be true. So this is true, so there isn't any contradiction out here. So what does this mean? This means that this equality holds for any value of x and y. That is, this is true for any given x and y. That means that this equations actually intersects everywhere, since whatever value of x and y we plug into these two equations, we'll still get a valid equality rather. So that means that the answer for this one is infinitely many solutions. And when does that happen? What can you observe in these two equations? These two equations are actually the same. Upon certain manipulations, you'll see that these two equations are the same. And indeed, if we show its graph, although it's not that easy to see, the two lines are actually overlapping one another or coinciding one another. And we know that when that happens, the two lines intersects everywhere or intersects at every point possible. So, indeed, the answer for this linear system is infinitely many solutions. And so that is how we apply the elimination method in solving linear systems or systems of linear equations. To formally end this, here's an exercise or a challenge that you can work on. So I know that so far we had only discussed solving linear systems in two variables. But as a challenge, you can try out this one, which is now in three variables. But take note that you can solve this one by applying the elimination method. If you can't figure it out, here's a hint. You can start with focusing on these two first. Observe that upon elimination, if you apply the elimination method, it is easy to get the value of y in here. Upon solving for y, you can easily plug it into the second equation to get x, and since you already have x and y, it's not that hard to get the value of z. So yeah, I'll be waiting for your comments in this one, and I'll try to check if you got it correctly, or if you're stuck, I'll try to give more hints on how to solve this. So yeah, that's it for this video. I hope you learned a lot in this one, and in the next video, we'll be solving examples on linear systems again, but this time more on the substitution method. Yeah, more on the substitution method. So yeah, that's it, and yep, that's all for this video.